mechanisms for demand-oriented optimization, tech planning, and tech control.
Thank you, Patricia, for the introduction. And hello, everybody. So the topic is adjustment mechanisms for the demand-oriented optimization in tech planning and tech control. And I just want to highlight, we don't talk about tech time planning, how is it often used here. We talk about tech planning because we don't plan the time, we plan the density, what Iris already mentioned in the morning. So within this paper, we had a case study with a general contractor in Germany. And what we did, we didn't look that much in detail how they do the tech plan. We just looked in their tech plans. But before we go into these tech plans, and I will show you a little bit about this, I will first highlight the as-is situation, how it was before they started and how it is still on the construction side. First of all, we talk about really dynamic systems. So we have a lot of changes over different project phases and everywhere on the construction side. And quite often we have a big gap or a big difference between the plan, which is hanging or which is in the system and hanging behind the site manager, and what they are doing outside. And what we use traditionally is a Gantt chart, line of balance, task list. But if we really go in detail, this way of visualizing things can get really complex. So what we figured out is that we find a visualized method or way how to present it, that it was quite easy for the workers to talk about this. And also, as more detailed the plan is, as more I have to change. I think this is also a reason why it's not really often updated. So tech planning and tech control is the kind of method which can help, but what we figured out, I already mentioned it, it's a really good visualization. So what we observed there, when we hang this plan on the wall, everybody was talking about this plan. But I heard a lot of points, negative points about this method, that it's quite a fixed method compared to the last planner system. And the question which is always asked after we do a presentation and we do a kind of lecture, what happens if something goes wrong in this plan, and in this tech plan, and how we react on this. And these questions we were highlighting or we were caring about in the paper. So let's jump into the tech plans. This, as you see, and how Clarissa already mentioned in the morning, on the vertical line you see the area, on the horizontal line it's the time, and sorry for that, it's in German because it's just a screenshot out of the tech plans which they use. And within this grid between the lines, we have different boxes, and we try to fill this box with different tasks. And we can do it in different ways. You can do it in the way that you just fill different tasks, different boxes, and just fill it. And you can also do it in that way that you create a kind of flow. And what we figured out, you have different kind of flows within a tech plan. So you have the horizontal line. This is the client's perspective. And for the areas, you have different flats in this example. So if you look at the client's perspective in the horizontal line, you can see easily a kind of flow, and you see also from the client's perspective what is the status of my flat and what's the duration time. And you also have the diagonal flow. This is the trade perspective. So we just said to the trade, look, you're the purple color. So look at your flow and look that this flow is continuous. What you see here in this tech plan, we divided the tech plan. So we call it trains. So we have two kind of trains to create a flow there and do the activities. And this is the as-is, or this is the situation how we planned it before we started the activities. And this is the tech plan, how it looked like after we finished the construction site. So we are not talking about kind of inflexible system. This system is quite flexible. It just gives you the structure. And it was really easy for the workers to discuss and say, let's skip this task to there. And you easily see what happens with the flow. So the flow is sometimes interrupted, the horizontal and the diagonal flow is interrupted. And what we did in this paper, we looked at this tech plans and tried to figure out what are the repetitive types of actions which we have done. For example, you can see sometimes this vertical line where we really stop the production. You can see simple or single boxes where we just filled in and put the train out, just divided the train, or you see just some single gaps. Another example with 3 trains. First of all, you see already during the planning phase we already integrated one. After this gray box, we already integrated one buffer or one gap. It was just for the drying time for the floor. And this is what happens after we finish this construction site. So what I want to show you, and we have 40 other different examples, what I want to show you is just we work with this time schedule. It's not like it's one time fixed and try to stick to it. We work really with it. What we did, we had a look on this different time schedules or tech plans, and what we did, we created a kind of list, and this topic came up because we had a discussion last year with Olli Seppinen, and he said, okay, we were doing changes, but let's name them, let's categorize them, and that's what we did. So we figured out that this construction company uses 31 different types of actions or adjustments, or last year we called it moves. What we did, we created a table, we named them, we give them a name, and we tried to use the name which they already use on the construction side. We made a list and scheduled it or brought it in the way that we said, is it more in the planning phase or is it more in the control phase? And we also categorized them in the way how often they are used. So category A means in this 40 project they were used more than 30 times, and category C is they are less than 5. Category B is for sure between. We described them, and we also showed what kind of effects they have based on the time schedule from the client perspective and also from the trade perspective. This is just a shortcut out of this list with this 31 adjustment mechanism. Right now I would like to tell you or talk about 2 of these adjustment mechanisms and describe it a little bit more in detail. So this one you have already seen in the tech plans before. We call it strain stop or stoppage. And where the idea comes from, it's from the basic idea of Toyota. So about the waving loom, they invited this waving loom and said, okay, if there's a problem, let's stop the process and care about the quality. And we just want to produce if the quality is fixed. And this is the same mechanism what we do here. So we stop the whole conveyor belt or the whole production and say, okay, let's take care about this problem, and then we will continue if the problem is fixed. So as you can imagine, if we are outside and there are, I don't know, 50 workers and you really stop and say, no, you're not allowed to work anymore. In the beginning it was a really big problem, so you have to really change their mind and say, okay, let's concentrate on this problem. And really we stopped sometimes for just 1 week. Just 1 week, and we concentrated on this problem, but not everybody concentrated on this problem, just the group which were responsible for it. The other jumped into the work backlog areas and did there some tasks. But we stopped really the production in this area. This is just one mechanism, but it's a mechanism which is used quite often. Another one is the soft start. So if you talk about different trains, sometimes we let them start parallel, but sometimes we really make a gap between them and say, okay, train 2 starts a little bit later. For which reason? It's for the reason that the idea is to learn from the first train. So we should not make the mistakes which we did in the first train. We should not make in the second train again. So this is our idea of continuous improvement. And also we would like to reduce the workload in the beginning of the production. We'd like to reduce it a little bit, so that they have really time to concentrate on the quality. These are just 2 out of 5. We explained 5 a little bit more in detail. We also have all other 31 a little bit more explained in detail, but yeah, there was just didn't fit into the paper, so I think we will continue on this topic. And we also found out that we have 100 other ideas what kind of mechanism we can use, but we don't use them right now in this company which we observed. So just as a short summary, what we figured out is this company really used only the tech plan or this visualization of the tech plan. They just used it as a kind of framework, and then they discussed about it. So what they did as a kind of idea, they put out the buffer of every box, they put it out and put it in the end of the tech plan, so that the adjustments, it was allowed to do the adjustment. But what's really the goal of this paper or the idea behind? Right now we named them, we can categorize them, and now we can use them in a systematic way. You can really say, okay, let's do this action or let's do this action, and you can combine this action and really choose one. Right now they just did it by their feeling that they should do this. And we really can say, okay, which kind of effect it has on the production schedule and also on the flow. So it's a perfect way to this tech plan, how we see it, it's a perfect way to discuss with the workers, with the client, and also between the different participants of the general contractor. And the goal is really, or what we do is we have this adjustment mechanism, or we have this adjustment on the construction site because we have really unstable conditions. So we have to adjust something there. It's not possible right now, and I think also not in the future. So we have them, but we have to work with them, and we have to really we have to really use them in a systematic way. And the idea is for sure to reduce this action. But there's also a difference between if you react on a problem or if you act. So if you see the problem in front and you just do an action and kind of planning, you planned it, or if you just react on this. And for sure, if you see it like this, every adjustment has a kind of influence on the flow. Sometimes a positive, if you plan it like this, but in the most cases, it has a kind of negative influence on the flow efficiency. That's the last point I already mentioned. But what we would like to do is we created so much data and we can categorize it. I think sometimes right now we can already precast problems in the sense that we see, okay, there's a little problem. What does it mean or what will happen if I don't stop the train? What will happen if I just bring in one single gap? What will happen if I do another action? So we can really precast problems, and we can precast what happens with the time schedule. What's the duration time? What's the effect on the duration time? What's the effect of the duration time of one flat or the whole project? This is the idea behind it. So, thank you.